Alright. Routers and switching. NET-225. So this gets us, up to 2 weeks after spring break. So what have we done? We've done, everything VLANs, and then we did from VLANs we started into items for routing, and routing involved with routing from VLAN to VLAN. So start off. Any questions? What we've done, where we're going to go. Chapter 6 was done Monday. Chapter 7, we've finished that already. So we covered a few key things. Do you know how the process works? Curriculum and the content, doing most of the labs in class, packet tracer on your own. Can you perform the skills? You're keeping some journal work, the labs, and the work to prepare for the skills. And the will. Do you care about the course? Are you putting forth the effort? Do you find the value in the course? And so forth. So, that's where we're at to move forward from here on. Talk about dynamic routing, static routing, layer 2 switching. These are the key things. Layer 3 of the network, layer 2 the data link. We talked about these protocols, 802.11, 802.3, security for 802.11, and we talked about LANs and Ethernet. Multi-layered switching. That's where the term multi-layer comes from. We have multiple layers. Then you can see the students had they had an example that we're working on in class. I talked about static routes. You static back in. They had a branch. Default out. We connected to a device I had. That device took us up to a switch, to a multi-layer switch, and eventually out to the internet. That was VLAN 20 that we were functioning on there. They had the connection between here, this router, and what the lab called the ISP router. And the students had their networks on those routers. So a key thing here was, again, to talk about they had these networks that had to communicate. So from here, you were good going out to default out, but this ISP and the headquarters, if this ISP needed to reach this network, it had to have a static pointing back down in. And here we had to have a static pointing back down in. It was a good lab. The students, you can tell the students did the writing up here, designed it out, and put everything together for. Here we're more formally talking about static routing, dynamic routing. Okay, again, I talked about default out, static back in, internally, going to the outside. Protocols, packet switching, and these are called routing protocols. RIP, EIGRP, OSPF are the ones we deal with. Distance vector routing, you learn information from your neighbor and use that to build your routing tables. A link state learns about the entire network. Okay, so link state, we're going to learn OSPF. Distance vector, we're going to learn RIP right now, and then the next term we cover EIGRP. How does a routing protocol pick the best route? So if you look here, you have all these routers in this network that could be the internet. And we have two different accesses into the network. How do we know which is the best way to go to maybe this network right here? Well, you have some type of cost, and that's measured by a metric. It could be hops, delay, bandwidth, and there are many others. And we'll talk more about some of them later on. Actually, these are the main ones we talk about. this term. Alright, so bandwidth, you know, if you have different bandwidths out here, you can easily add up the cost of all the bandwidths, and you might find, let's say, the red route might be better to go this way, you know, even though you may not think this is the best route, here and into the network. Now if you're going by hops, hops are the shortest hops. This hop, this hop, this hop, this hop. But if this is extremely slow and extremely slow and extremely slow and all the rest of them are extremely fast, that might be a better way. Routing protocols figure that out by sharing information between the routers. Once they shared information and they have their routing table up to date, then they say they have converged. Alright, so here's a little more of the same thing. Puts the best routes in, even though there are other ways to go. It puts the best route to get there in the routing table. So this routing table really only needs to know, I'm going to send it that way or that way. This routing table really only needs to know, you know, if this is the only way to go, or is there another route here. This router out here, its routing table, based on getting to here, knows either this way is the best, this way is the best. It's not likely good to send it back the way it came. That wouldn't make a whole lot of sense. And we say the whole thing is converged once all these routers have the best paths for all the possible networks, wherever those networks may be. Alright. Then we talked about the metrics. When the IP addressing was first created, that was classful, for example, we had, these are just some examples of private, you know, at least they're the start of private addressing, classful. But they look at classes, like 172 is in a class, 192 is in a class, 10 is in another class. And and you'll see the hierarchy in the routing table based on classful. Nowadays we are primarily classless. Once we go to IP6 entirely, that would be then entirely classless, and we wouldn't have to have that hierarchy. But until we get there, it's very important. Variable length subnet masking has allowed this then to work classless instead of always being on the class line. Slowly this is disappearing. Since we're doing this and classless inter-domain routing, the idea of classful is just so you understand the routing table. We talked about IP route, next hop. I gave the example, sometimes you have to get the next hop, like in frame relay. If you give the interface, and this link is up to the cloud, but this link is down, this router would not know that that's not available, and so it could start sending packets into the cloud. But if you give the next hop, you know, over here, then that route won't go in this routing table if that next hop isn't there. But this does cause a recursive lookup. And we've talked about recursive lookups. It finds out it has to go here, then it has to find this address to find the interface to send it out of. One last thing over here, we talked about if you have all of these addresses, 192.168s in this cloud, so you have lots of networks in this cloud, lots of different places to go, but they're all 192.168s, then you can summarize this address and send all the 192.168s to here. Then, if you get a network here, and that one's 192.168.1, and you're sending all the 192.168s into this cloud,
how are we going to get things to this network? Well, here's the situation. This is a /16, so that's 192.168.0.0/16. So it's just going to look at these bits here. But this one up here, if that one happens to be a 192.168.1.0/24, the 24 is more specific than the 16. So it's going to take and consider this one. It'll look at more bits in considering this one. So this information will not be sent into this cloud here. It'll be sent here because of the 24. That's an important part of IP addressing. So if you have addresses that all look the same, you want to look at what is more, how many more bits. The more bits it looks at, the more specifically the bits it looks at, compared to the other one will be the one it'll take if, for example, this part, and I'm using that color, in this case, this part and this part match. That's it.